आइए हम सुने विज्ञान की अनकही कहानियां.
Join us as we unlock earthquake resilience with Dr. DrDevajit Hazarika from the WIDA Institute of Himalayan Geology, whose research turns cutting-edge science into actionable steps, equipping communities to stay safe, minimize damage, and save lives when the ground shakes.
I am Dr. DrDevajit Hazarika. I am working as a scientist E in Geophysics Division of WIDA Institute. I am working in the seismology. I am carrying out seismological work since 2007 in this institute, and basically we are monitoring the seismic activity in the Northwest Himalaya and Northeast Himalaya. So I am involved in imaging the subsurface structures beneath the Himalayan regions, and how these subsurface structure can be related with the seismicity, and how the seismic activity in the Himalaya can be related with the tectonics. Those kind of study we are doing. So these are the basic works that we do, but our institute is also working towards the identification of the seismically active fault zones, which are very much important. As everybody knows that earthquake cannot be stopped. We cannot have any technology to stop earthquake, but one thing we can do, that we can educate ourselves, we can educate our child how to live with earthquakes. Because nowadays we know that Japan and China, they understood how to live with earthquakes. To live with earthquakes, we should understand, we should apply our understanding on the civil engineering, this constructing the earthquake resistant buildings, and also we should aware about the active faults, because if we see in the Himalayan region, we always find that there will be some active faults and there will be nearby villages, and people may not be knowing that this is an active fault which can generate earthquakes in the future. So those kind of things are important. And next thing is that in schools we should educate our child how to safeguard ourselves from the earthquake, because earthquake doesn't kill people, only the infrastructures, the buildings and other things, they kill people. So if they at least know the minimum basic things, that where to run during an earthquake, how to safeguard themselves, those are the minimum things that one should get educated. So if we do mock drills, like our institute is getting several mock drill practices, scientists go to different schools and colleges and also in villages, and they educate people about this kind of exercises, that what to do before earthquake, what to do during earthquake, and what to do after occurrence of an earthquake. If we educate these school children, they will be prepared for such kinds of incidents, because we are staying in the Himalayan regions, and basically most of the major cities are located in the Indo-Gangetic plain, which is very much loose sediments, and people are constructing multi-story buildings in Delhi and other cities. So nowadays the major concern many people say is that we should have the early warning system, we should have can we predict earthquake? First of all, that is the major question that people ask. So now I should say that now till this moment there are several efforts have been made by Chinese and many other people globally, even in India also, but earthquake prediction is not possible till date. So what we should do then? Then the first and foremost is that we should learn how to live with earthquake. That is one. And next thing is that people talk about the early warning system. It is very good, because now IIT Roorkee and many other people, they are making their effort to make the early warning system. But still there are several doubts that how early we can give the warning, because this most damaging wave is because in earthquake wave there are two kind of wave. One is P wave and S wave. So when the S wave interacts with the surface, then it generates surface waves, and those surface waves are the culprits for destroying the buildings and bridges and all these things. So those surface waves, they are very slow in speed. So people can take the advantage that before reaching the surface wave, they can give an alarm to the hospitals, to the school, and to the electricity, and to stop the bullet trains. Those things people are trying to do, and people are successfully doing in Taiwan. We visited once Taiwan, and we have seen that infrastructure, and they have developed it. But the now major question is that cities like very crowded cities like Calcutta or in Guwahati, if you put an alarm before 20 seconds, then how it will help? And I think that many people will die because of the warning. So there may be some advantage and there may be some disadvantage, but you can stop the electricity, you can stop bullet trains, and you can stop the traffic. Those things can be minimized, and I think these are efforts. Now, what our institute is doing, I am basically involved in imaging the subsurface structure based on earthquake data. So for us, for chemistry people, they need the reagents. We need earthquakes for studying. Unfortunately or fortunately, we need earthquakes for studying our planet. So those things we are doing because if you do not know the foundation where you are sitting over, then how we will study the seismology, how we will study the other things. So we do give the emphasis, and we found out several causing mechanisms of the earthquakes in the Himalaya, and we found that in Himalayan region, mainly we found the shallow seismicity, which is occurring around 10 to 25 kilometer depth, and we relate these with one interface. As everybody knows that Indian plate under thrust beneath the Himalaya. So Indian plate means it is Indian shield rock. When it under thrust, that plane separating the Himalayan wedge and the Indian plate, that is called the main Himalayan thrust zone. This is a plane. So many scientific studies observed that there is a ramp structure in that main Himalayan thrust or the detachment surface that cause several micro earthquakes activity in the northwest part of the Himalaya. But we have observed from northwest to northeast, and we observed that these causing mechanisms of the earthquakes are different in different segments of the Himalaya. In whatever the causes that we are finding out in northwest Himalaya, it is not exactly similar in the northeast Himalaya. Because in the northeast Himalaya, entire crust is active up to the crust mantle boundary, whereas in the northwest Himalaya, earthquakes are up to the shallow focal depth. Okay. It is useful in the sense, as you know, that these are the basic science that we do. The first and foremost is to understand our planet, to see the structure of the crust, mantle, all these things we talk about. This directly doesn't, it is not directly applicable to the society. But the thing is that we are creating a knowledge base for the next generation, because as I told you, we cannot predict earthquake, we cannot precisely give early warning. There are so many issues. But if you compare with other countries like Japan and China, we can educate the people, we can talk about the active, seismically active fault zones. We can say people that these are the pockets of where the earthquake can occur in the future. Those things we can say, though, because people can construct big farms and they can construct big factories, and so many things are there. So these concerns will definitely help people. And next is we can also jointly work with the civil engineers for constructing the earthquake resistant buildings. So those are the indirectly, although it is indirectly, but it goes to the society. Initially, in our PhD time, I worked in Northeast India for seismic wave attenuation, earthquake source modeling, and all these things. And we now know about the seismicity patterns and why earthquake occurs in the different parts of the Himalaya. So I am working on this subsurface imaging, but in the next phase, I am very much interested to go much deeper, like the mantle depth, because we are working up to 400. There are several global discontinuities like 410 and 660 kilometer discontinuities. So those things also, those are for these theoretical things. It doesn't directly go to the societal impact, but we will be able to know about the deeper geology based on our geophysical imaging exercises. These are some projects we are working, sponsored by the Ministry of Earth Sciences. So these are the future things that I am in near future I am going to do. This seismology is a very young science, because many theories comes in 1960, and so we know only plate tectonics just few years back. So this is a young science. So everyone is young in this field. But still, if we talk about our status, our position in this seismological field, we are now in much advanced stage, because we are publishing very good papers. Like our Indian scientists, they are publishing in Nature and Geoscience and Nature, and we are also in our institute. We have published papers in several reputed journals like Journal of Geophysical Research, Geophysical Journal International, Tectonophysics, and many other reputed journals. So we are thinking that we are in a very good position, but we should much more we have to develop. Not only us, but globally, this subject is new, so we have to work. We are not competing with others, but still we can say that there are several reputed universities like Stanford University and many other people. We are doing collaborative work with them. We are discussing with them. So they have the much more advanced technologies. They are developing theories. So that is not we are competing. We are just trying to learn from them. We are working for hydroelectric projects, not directly industries, but still the industry people also they take informations regarding the earthquake activities, because if they, as I told you earlier, if we construct a big industry in the MCT zone, then people will immediately see the cracks and other things, because if you go to the Himalaya and see the MCT zones, you will find cracks in the buildings of different buildings of the villages. So they always nowadays for everything, for constructing road, for constructing buildings, for constructing industry, they need the information of the earthquake activity. Yeah, research papers. Recently, we have published research papers in Geophysical Journal International, then Geophysical Journal of Geophysical Research and Tectonics. Many research papers we have published here, because we have established 80 seismological stations in WIDA Institute, and we are generating huge quantity of microseismicity data in this region. So that is progressing well, and we are working for it.
This podcast series on STEM popularization is supported and catalyzed by National Council of Science and Technology, Communication, Government of India. Produced by Media for Community Foundation. Technical support is given by Soumya Mishra.